we started with Trino part. Okay, we didn't see the practical part, okay, but we started with Trino part. Okay. Any questions in that? Any questions? Okay. So if no questions, okay, I'll start with my session. No questions, right? Okay. So I'm starting with my session. Okay, so we discussed about, okay, so we discussed about Trino. What is Trino here? So normally, okay, normally if you say any company, so you will be having data, okay, stored in different databases, or okay, different data lakes, or maybe some data in data lakes, okay, some data in cloud, okay, some data in RDBMS. Okay, so this is how, okay, people will be storing the data. Okay, but okay, see, storing is fine. Okay, wherever you want, okay, wherever you have the storage, okay, you can store the data. But only the problem here is that querying, how you access the data. That is a big problem actually. Okay, so normally when you have data stored in separate databases, okay, accessing is a big problem. Okay, so only the solution we have is, okay, so bring all the data into common place. That common place can be a warehouse or a data lake. Okay, data lake. Okay, and then, okay, so we need to execute the queries on top of that. But okay, with the help of Trino, okay, Trino is kind of a solution to run queries across okay, different platforms, actually different storages, that I would say. Okay, it is not like, okay, so only database or okay, only data lakes and all. Okay, so Trino has the capability to connect to any data source. Okay, any data source until unless they provide the driver. It can connect to almost 35 different data sources as of today, and it can get the data. That's the power of Trino. Okay, so when it comes to Trino, okay, you will be having, okay, a cluster concept here. Okay, so the master service is called as a Trino coordinator, and the worker services are called as workers. Okay, so whenever, okay, any query is submitted, okay, the query will be given to the coordinator. Okay, so the query will be given to coordinator, and okay, so the coordinator will, okay, do the query validation, like, okay, it will do the syntax check, okay, and okay, it will create a best execution plan. Okay, it means it will divide the query into stages. Okay, the stages will be for the developer task. Okay, and this task will be given to the workers here. Okay, so what we will do, okay, so we'll see some practical case. Okay, so yesterday we have installed Trino, and this is the Trino UI, and you can clearly see that there are 3 active workers. Okay, and this is the Trino cluster name, batch V31. Okay, and this is the Trino version of what we are using currently. Okay, so what we will do now, okay, so we will see some practicals. Okay, so as I told you, okay, Trino is kind of a system, okay, which can extract data from multiple data sources. Okay, so now, okay, I will log into HN4. Okay, now, okay, we need to extract data from 2 different places, right? Okay, so what we can do, okay, let us extract, okay, let us create databases, sample databases here. Okay, so I'm taking this as a, okay, so you can see here. So I'm going like this actually. Okay, so this is database, okay, this is the MySQL database. MySQL database, which is running on hn2.hadoop.com. Okay, and okay, I have another MySQL which is running on different machine. Okay, I think that this is a Postgres, okay, but I don't have Postgres DB. Okay, but I'm just giving an example. Okay, so this is running on HN3 machine. Okay, so now, okay, so let us prepare the databases actually in HN2 machine. Create the database table and insert some data. Okay, so now I will log into, okay, log into HN2 with STP user. With STP user. Okay. So once you log into HN2 with STP user, so where is HN2? This is HN2. Okay. Just okay, start the MySQL which is already here installed here, and okay, now okay, I'm creating a database here. Okay, so what is the database we are creating? So database is IBM. Okay, and I'm creating a table also. Okay, I'm creating a table also. Okay, yes, it is done. Okay, now okay, I'm going to insert some data. 7 records. Okay, I'm inserting now. Okay, 7 records I inserted. Now okay, if I see, okay, there are 7 records. Okay. So employee ID, employee name, and department ID. Okay, so these are the 3 columns of what we have in the employee table. Okay, so it means okay, so this is the database H3 and 2. Okay, okay, so I'll take it here. So this here, okay, so I created a database okay, which is IBM. Okay, and okay, we created a table which is called as employee. Okay, so these are the 2 things which we created here. Okay. Now what I will do, will log into HN3 now. I will log into HN3 machine. Looks like it is already running here. Okay, now I'm creating a DB tables. Okay. So this is the DB I created. This is it. Okay, so company is the DB. Okay, and table name is DEPT, department. Okay. This is the table I created. So now, okay, inside this one there are 7 records. Okay, there are 7 records inside this one. What is this one? Okay, these are the 7 records, and okay, here okay, I have 3 records. Okay, 3 department ID, department name. 1 IT, 1 IT, 2 HR, and 3 finance. Okay, so now okay, if I want to execute a query, okay, these are the 2 different databases what I have. Okay, if I want to execute the query and or if I want to join these 2 tables, okay, it is not possible directly. Okay, what we need to do? So we need to use Trino. Anyway, we created Trino, right? Okay, so first, okay, we need to tell Trino, okay, what is the location? What are the details about this first data source? Okay, so now what I will do? I will log into coordinator node. Create catalog only in. Okay, log into what is the HAM machine? This is the log into HAM using Trino user. Okay, so I'm logging into HAM using Trino user now. Okay, so this is the Trino user. Now here, okay, I'm creating a catalog. Okay. So this is the catalog file, guys. Okay, so normally catalogs will be stored and it will be stored under your installation under the etc catalog directory. So this is the okay, property file which I'm opening. So here I'm telling that what is the connection string for data source 1. So here I'm telling that okay, the data source is MySQL. Okay, so character name is MySQL. Okay, URL is ddbc:/MySQL. So this is the IP address 123. Okay, and okay, username is root and welcome is password is welcome1. Okay, this is what okay I'm telling about the first data source. Okay, in the same way I'm creating connection string for the second data source. And where I'm creating these two? Where I'm creating these two? Inside Trino. We understood that we'll go and extract the data from the sources, right? So we understood that Trino can extract data from different data sources. This is what we understood. But okay, how Trino will understand okay how to access this one? How Trino will access this data source without providing the details? How Trino will access these databases? Okay, data lakes without providing the details. Okay, so you need to provide the details. So we have a Trino cluster here. So this is the Trino cluster. Okay, so this is the coordinator node. Okay, this is the coordinator node. And okay, this is one worker node. Okay, so worker 1, worker 2, and worker 3. Total 3 workers we have taken. This is our coordinator. This is the coordinator node. Okay. So now, okay, so this is the worker. These are the workers. Worker 2, worker 3. So here, okay, you have worker 1, worker 2, and worker 3. Okay. So now what I'm doing, okay, I'm creating a catalog here. What is the catalog here? Normally, catalog means, okay, it's a file which contains the data source details. Okay, what is the type of data source? Okay, what is the IP address? Okay, what is the port number? What is the username, password? So basically, okay, these are the this is kind of a connection string. Okay, how to connect to the so here, okay, what I created, MySQL included property file. This is the catalog. This is another catalog. Okay, because okay, I want to access these two data sources. So I created two catalogs here. I created two catalogs. So once, okay, like this, okay, you can create any number of catalogs. There is no restriction dates. Okay. So now copy these catalog files to other nodes. Copy these catalog files to other worker nodes also. It means, okay, so these two files will be available in worker nodes also. So these two catalogs will be available here also. Okay, this is how, okay, so the catalogs are available in coordinator and even worker nodes also. Okay, now my Trino is ready. So normally whenever you add a catalog or modify existing catalog, you will have to restart. You will have to push the changes to all other nodes and restart the Trino services. Since, okay, you made the catalog changes, catalog you created the new catalogs. Now, okay, I'm stopping the Trino and I'm starting the Trino. Okay, so now the Trino service is started. Okay. So this is what is happening now. This is what the sample query is. Okay, you have database 1, database 2, and okay, this is your Trino cluster. Okay, and this is okay. You will be checking now. Okay, so what you are doing? Okay, now you need to open the Trino CLI or DB1. Okay, this is the Trino CLI. Okay, so where I'll open? Okay, so you can open on any node. Okay, so you can open on any node. Okay, let's say I'm opening it on coordinator node. Okay, so now while opening the Trino CLI, what you need to do, you need to provide the coordinator details and coordinator port number, and okay, which catalog you want to use, and okay, which schema you want to use. Okay, these are the details. Okay, so here, okay, I have given the catalog name as MySQL HM2. Okay, and this is the schema. Okay, even if you don't give catalog also, that's fine. Okay, but okay, so you can connect to this one. Okay, so or you can just connect to coordinator. Okay, so you connect it to coordinator now. Okay, you connect it to coordinator. So normally when you connect to coordinator, okay, this is the prompt you will get. No prompt you will get. Okay. So now let us try to run some commands. Okay. So if you want to see, okay, if you want to see how many worker nodes, okay, we have in this cluster, okay, you can use this command. Okay. This will tell you, okay, so how many nodes we have in the cluster and who are the coordinators and who are the workers. Okay, so in this cluster, okay, this cluster is made up of total four servers. Okay, the first one is coordinator 2. It means, okay, the first one is HM is the coordinator, and okay, HM1, HM2, HM3, these are all workers. Wherever you see coordinator false, okay, that is nothing but your worker. And this is the version of Presto. Also, this is the version of Trino, and okay, the current status is active. Okay, so now okay, I'm saying that okay, show schemas from MySQL HM2. Okay, so Now when I say show schemas, this is nothing but show databases. Okay, show database, will it work? Okay, show databases for, okay, so it is saying that, okay, so there is no word called databases. Okay, so here, okay, there is a word called schemas. This is the word, okay, we have. That is the reason we need to use show schemas. Okay, now what it is saying, it is showing the databases from MySQL H2 means, okay, from this database. It is showing, okay, there's a DB, okay, IBM. Okay. In the same way, okay, I want to see the databases from H3 machine. Okay. So here, there's a database which is called as company. Okay, guys, you try to understand. Okay, see, by sitting in one place, I'm able to access database 1 and I'm able to access database 2. Okay, so from one place, I'm accessing both databases. Okay, now, okay, let me run some query, join query. Okay, show tables from this. Okay. Show the tables from H2. So here, okay, how you refer, how you need to refer, you need to refer your catalog name, okay, dot database name, dot table name. This is how you need to define. Okay, so here in this catalog, from this catalog, okay, from IBM database, okay, so how many tables we have? Under IBM table, we have only one table, employee. Okay, so what next? Okay, describe this table employee, IBM employee. Describe IBM employee. So this is what employee ID, employee name, department ID. This is the description of IBM employee. Okay, so you want to see the data from IBM employee. I think here how we are giving. Let's start from catalog name dot, okay, database name dot employee table name. Okay, so this is how you need to give. So there are total 7 records here. Okay, in the same way, let us see the schemas. Okay, here, okay, so this is showing the schemas from HN3. These are the total 4 schemas we have in HN3. Okay, and okay, so if you see the second query, so from company, okay, what are the tables available in the HN3 dot company? This is the one. Okay, these are the tables. Okay, DEPT table. Okay, what is the description of this DEPT table? We have department ID, department name. Okay, and this is the data, okay, of the DEPT table. Okay, there are 3 records. Okay, so now I'm able to see data from both the databases individually. But okay, now I want to join a query, or I want to run a query to join the data between both the databases. Here it is. I'm getting my output. Okay. See, okay, what I'm doing, I'm selecting employee ID, okay, employee name from, okay, then department name. Okay. So here from MySQL.IBM employee inner join, okay, company department, where department ID equal to d.did. Okay, order by 1. Okay, so did I join 2 tables or not? Now tell me. Yes, I joined 2 tables. Okay, and okay, both the tables are from same databases, or okay, same instances. Okay, so here, okay, so you have separate databases. Okay, here, okay, you have employee table, and here, okay, you have the DEPT table. Using Trino, okay, what you have done, okay, you join these 2 tables, but okay, without moving data to common place. You didn't move this data to any common place. Okay, this is one. Okay. So if you want to run your queries without logging to Trino CLI, okay, you can run your queries without logging to CLI also. Okay. What you can do, just quit this one. So if you want to run a query, you just put this query in a text in one file. So now I'm creating a query.txt file. Okay. Inside this query.txt, query.txt. So this is the query what I have, and okay, you just pass this query.txt. Okay. So when you run this command, okay, Trino CLI server -f, you are passing the file, query file. Okay, this is the query file, query.txt, and output format you are saying that CSV. So it means, okay, so whatever the output you generate, okay, this query will generate, okay, that output will be shown in a CSV format. This is a CSV format. comma separated format. Okay. And okay, now you want to see the same thing in TSV format, tab separated. Okay. Now you will get the same data in a tab separated. So one tab, Venkata tab IT. Okay. But you want to store this one in some file, this output in some file, you can redirect actually. Okay. Output.tsv. Now you see, this is the output.tsv. Now you see, okay, data is in a tab separated value. Okay. So like this, okay. So you can run queries. Okay. If you want to generate the same output in a JSON format also, you can generate in JSON format. Okay. So it will support okay, different formats also. Okay. Output.json. You know, entire data has come in a JSON format. Got it. Okay. So this is how you can run this from the command line. But if you feel that okay, command line query execution is difficult, then what you can do? So you can use dbeaver also. Okay. So you have something called dbeaver. So what you need to do? Okay. So here edit. Okay. So here this is the connection which I already added. So here database, new database connection. Okay. So now okay, you want to connect to Trino, right? Okay, just click on Trino. Next. Okay. Now okay, it is asking. Okay. So JDBC URL where Trino coordinate is running. Yes, this is the place. Okay. But okay, authentication method. Okay. So admin at this moment. Is it 8443? 8082. It's just a ticket request. These things. Okay. Okay, looks like we need to enable SSL, then only it will work. Huh? Now what will happen? Okay, so you need to connect to here. You need to connect, okay, here. Okay, so you need to create a new database connection. Okay, normally, okay, how people will connect to Trino, they will not go to command line and all. Actually, they'll not go to command line. Okay, so here, okay, they will open the tools like this dbeaver, and they'll click the new database connection. Okay, so and here, okay, so they will take the connection actually. Okay, so here, okay, they have a lot of connections. Okay, so Hadoop big data, so these are the tools. Okay, so they take this one. Okay, so you can connect to Hive directly from dbeaver. You can connect to Apache Phoenix HBase. Okay, then Cloudera Impala, Presto. Okay, so Spark. Okay, Dreamio, Presto DB. Okay, Snappy Data. Okay, so these are the different tools, okay, where you can connect. Okay, you can connect from dbeaver. Understand? Understand, guys? Okay, so looks like there is some issue here. Okay, so it's not working. Okay, so when I run this command, what it is saying? Disconnected from database. IBM. Okay. Okay. I'll show you the reason. What is the reason? That is enable SSL here. Then it will work. Okay. So these are the commands to enable SSL. I'm stopping the here in all the nodes. Okay. Now, okay, so I'm just adding some configuration. HTTP server enable equal to false, okay, to HTTPS enable equal to true. Okay. Then I can modify below configuration file. Okay, wherever you have 8082, now I'm changing it to 8443. Because okay, when it is when you enable HTTPS, okay, it should work on 8443. Okay, so now I'm generating the store and all. Okay. So what is this key store? This is the keystore.js I created. Okay. Now I'm creating a SSL directory and pushing this keystore file to other nodes. Yes, in all the nodes, okay, we have JS file and add this keystore properties in the configuration properties. Okay. Okay. So this keystore properties, okay, so are added, okay, in all the nodes actually. Okay. Now, okay. So Trino UI will not work without authentication. So what I'm doing here, okay, I'm adding the users here. Okay. So maybe Alan welcome one. Okay. So maybe Adam welcome one. James welcome one. Like this. Okay, you can add, okay, the users here. But in real time, okay, you can integrate this with your LDAP also, so that you don't need to add any users. Okay. So now I'm creating a password DB file and I'm adding this. Okay. This password DB. These are the four users, and this is the password. Okay. So now I'm opening properties file. Okay, inside this one, what we need to do? We need to put these two things. Okay. What is the authentication authentication type? And okay, so from which file we need to authenticate? Okay, this is the password DB file. So now, so it's done. All the steps are done. Now you start the Trino service. Okay. So it started. In all the nodes, okay, it started. But okay, if you want to connect to this one, so we need the JKS file actually. Okay, so the JKS file is in. So I connected to 121 machine. Okay, so from home Trino. Okay, in this. Okay, so this is the JKS file. So what I will do, I'll bring it to what is the dbeaver. What is the connection we use here? Edit connection. So here, okay, driver properties. Here, okay, C drive, desktop, Trino JKS. Okay, so we need to bring it to desktop. So desktop, Trino.js. So bring it here. Yes. Okay. So now you connect to Trino on 8443. Advanced. Okay. Now you can see this is with HTTPS. Okay. Now username Alan we have given, welcome and password. Okay, now you can see the UI, the same properties which we need to change in the dbeaver property file also. Okay, right click on this one, edit connection. Okay, so here username is Alan, password is welcome one. Okay, so this is okay 8443, right? This is not 8302, 8443. Okay. So now you connect to this one. Looks like it is working now. Yes. Okay. Now, okay. So now you can see. Okay. So MySQL HN2 and MySQL HN3. Okay. Inside this one, okay, what are the schemas we have? IBM information schema and performance schema. Under IBM, okay, we have what are the tables? This is the employee table. Okay. In the same way. So under MySQL HN3, okay, you have a database which is called company. Under company, you have a table called department. Okay. So now, okay, execute this query. Show tables from MySQL HN2. Okay, so these are the show schemas. Okay. Then okay, this is the tables from IBM. Okay. Then okay, it will give you the description, table description. Okay. Now if you run this command, it will show you the data from IBM.employee table. Okay, in the same way, I can see what are the databases we have in HN3 machine, and okay, how many tables we have inside the company database, and okay, what is the structure of DEPT table, and what is the data under DEPT table. Okay, and now if you want to run a join query, you can run the join query here itself. Okay. So normally in real time, what users will do, users will use okay, this kind of UIs, dbeaver, okay, or Power BI, or Tableau, okay, or ClickView, Pentaho. Okay, so these are the different tools they use to connect to Trino. Okay, so now everything is working. Got it, guys? Got it, or any questions? It means okay, by sitting in one place, I'm able to extract data from two different data sources and working here. Okay, so now what is happening here? So if you see this one, software enabling this one, it is like this actually. Okay, so now same thing. Now this is not a Trino CLI, this is a dbeaver. Okay. Now user query will be given to dbeaver. dbeaver will connect to coordinator, and coordinator will, okay, so every time you give a query, you give the query in the dbeaver. Okay, dbeaver will send it to coordinator. Coordinator will pass your query, and okay, so create the query into, or divide the query into stages, and divide the stages into tasks, and task will be given to each worker. Okay, so since each worker has the catalog file, okay, each worker can connect to any of the data source without any issues. Okay, so if you don't give your catalog file properly, then okay, so then okay, your Trino will not be able to connect to any of the database here. So earlier it is like a Trino CLI. Trino CLI. This is what we did. Okay, here. Okay, but now so using dbeaver or Power BI. Okay, so you can use Power BI or Tableau. So you can use any tools actually. This is how you will be able to extract data from different data sources. In real time also, this Trino is becoming very, very useful and powerful tool in future. It's already powerful tool now, okay, but okay, this will become okay more and more powerful because okay, it has the capability to extract data from different sources. Okay, and again, this tool is from Facebook. Normally, if there is any tool from Facebook, okay, that will become super duper successful. Hive also from Facebook. See, you cannot imagine Hadoop without Hive. You will not have any cluster in the world without Hive. Got it? Got it, or any questions? Okay. So that's all I have from no guys. Okay, so let's come back to the theory part here. Yes. Okay. So coordinator, normally this is the master service and worker is a worker service. Nothing much to talk about this one also. Okay. So connector is the one, okay, so which is nothing but a driver here. Okay, and catalog means okay, every catalog is associated with a specific connector, and Trino catalog contains credentials and schemas of a data source via connector. Okay, so we can have more than one catalog use the same connector to access two different instances of similar database. Okay, so to connect to the same database, okay, so suppose here, okay, so to connect to HN2, I created a catalog with the name MySQL underscore HN2. Okay, maybe somebody else, okay, will may create one more catalog, okay, with a different name, MySQL dot HN2, okay, hn2.hadoop.com.properties. Okay, so this for the same data source you can create multiple catalogs also. Okay, but normally in real time they create one catalog and okay for each data source and okay everyone will use the same catalog because tomorrow if there is any changes, if you make changes in one place, that is sufficient. Otherwise, okay, for the same database, okay, if you create your own catalog, if I create my own catalog, okay, so tomorrow if there's any change, I can need to change in all the catalogs. Okay, so this is how it is working, guys. So any questions you know, I'm happy to help you here. Okay, so query execution model into know. First, okay, you will give a SQL query or SQL statement. Okay, so which consists of classes, expressions, and predicates. So this is a normal SQL statement. So when Trino passes the statement, it converts a query into a distributed. Okay, it converts it into query. So if you give the SQL statement, okay, what Trino will do? Trino will convert that into a query and create a distributed query plan, which consists of series of interconnected stages running on Trino workers. And okay, and a query is made up of stages. Okay, those stages will be further given to task. Those will be further given to splits and okay, and connectors and other components, data sources working in concert to produce a result. Okay, so when a stage, okay, so when a Trino executes a query, it does so by breaking up the execution into a series of stages actually. Okay, so we'll do one thing. Okay, what it will do when I run explain. Explain. Okay, explain. Okay, it's given a query plan actually. Okay, so this is the query plan actually. This is the query plan. Okay, so output expected is okay, employee ID, employee name, and department name. Okay, so employee ID is coming from okay, original column name the ID, employee name equal to E name, department equal to D name. Okay, so like this, okay, it will divide the query into stages, and the stages will be further divided to tasks, and okay, these tasks will be given to different workers. Okay, so that's how the query execution will happen. So yes, that's how the query execution will happen. Okay, so but okay, so as a Hadoop admin, we don't bother. Okay, so it is dividing into stages and all. But okay, whenever there is a performance issue, yes, okay, normally we use okay this explain plan. Okay, and okay, this is the Trino setup in production. Okay, so normally okay, how you will have okay, you will have a Trino cluster. Okay, so using these tools, these reporting tools, okay, ClickView, MicroStrategy, Tableau, Pentaho, dbeaver, okay, or Superset, okay, or Excel, okay, Redash, okay. So these are the different reporting tools what we have. Okay, so using these reporting tools, okay, so you will be connecting to the Trino cluster. So this is your Trino cluster, okay, with a setup, okay, one coordinator and multiple workers. Okay, and okay, inside this Trino cluster, okay, you will have catalogs, which will point to any of the data source here. Okay, so here okay, Trino has the capability to extract data from cloud storage or any kind of RDBMS storage, Teradata, MySQL. Okay, most of the RDBMSs it will support. Okay, and NoSQL. Okay, so you can extract data from Kafka also. Okay, so or you can extract data from Cassandra, MongoDB. Okay, so Redis, and you can extract data from Hadoop also. Okay, understood, guys? Okay, so this is what okay, you can do with the help of Trino. So any questions on Trino part? Any questions on Trino part? What is this? And if you see the Trino, where we will install Trino. And okay, guys, now question is that okay, can I install Trino without Hadoop also? Can I use Trino without Hadoop also? Yes, you can use okay, Trino without Hadoop also. Okay, so whatever the tools okay I have written here, okay, Kafka, NiFi, Storm, Spark, ELK, okay, Trino, all these tools you can use without Hadoop also. Okay, but with Hadoop, okay, the performance will be super duper higher. Okay, but okay, without Hadoop also you can use these tools. Understood? Are any questions? Okay, so this is the cluster, guys. Okay, so tomorrow, okay, so you need to keep this in your mind. Okay, so tomorrow if somebody asks, okay, where do you install Hive? So these are kind of questions when you get in interview also. Okay, where do you install Hive? Where do you install okay HBase? Where do you install okay Storm? So will you install in Hadoop area or okay, separate area? Okay, so like this. Okay, tomorrow, okay, let's say if you are an architect, if you are trying, okay, if you are an experienced person and you are trying for a trying as an architect. Okay, so then also you can okay, suppose if somebody asks you, hey, I want to install Spark, can you suggest me whether it is good on okay, and these nodes are outside nodes. Okay, so you can suggest these things actually. Understood? Okay, and okay, it's always better to build a cluster in a proper way. Then only okay, by using best practices, then only you will get the good performance. Otherwise, okay, so you will not get very good performance from the cluster. You cannot see. If I want to run Spark here also, I can run Spark. Okay, if I want to install Trino on these nodes, okay, yes, I can install. But okay, so these nodes are Hadoop nodes, and okay, so these are majorly designed for Hadoop tools. Okay, and okay, these are also Hadoop tools. Okay, but okay, these tools can run without Hadoop also. Okay, so that's the reason. Okay, we need to be careful. Okay, we need to be careful while installing these services. Okay, clusters. Better to have a separate clusters rather than mixing the services with Hadoop nodes. Okay. So if tomorrow in the interview somebody asks you to explain your cluster architecture, okay, you should explain. Understand? Okay. When I say Hadoop cluster, it doesn't mean that okay, it is only this place. Okay. When I say okay, Hadoop cluster, if somebody asks okay, Hadoop cluster, okay, I will tell okay, Okay, in my Hadoop cluster, okay, we have total 2000 nodes. In the 2000 nodes, okay, so around 1800 nodes are data nodes, 20 edge nodes, okay. So okay, two UI nodes, okay, two RDBMS nodes, okay, and okay, so 15 were Spark nodes, okay, so and okay, 15 Kafka nodes, okay, 10 NiFi nodes, okay, so 10 Storm nodes, okay, and okay, 20 Trino nodes. Like this, you need to explain. Understand? You need to explain in such a way that okay, so this is my whole cluster. So this all together you call it as a cluster. All together you call it as a cluster, and in your cluster, okay, you have total 2000 nodes, okay, including all the services for each node. Okay, so you will for each service, okay, you will tell for Hadoop how many how many nodes we have in Hadoop, okay, how many nodes we have in Spark, how many nodes we have in ELK. All those things are important. Okay, so that will give you a picture to the interviewers that okay, you are a real-time person or you have experience in real time. Okay, so far okay, we have seen these many tools. Okay, so now what we will do, see all these days, okay, we have seen, okay, so we have seen many tools, okay, from almost okay, from 15 plus days, okay, we are okay, we are talking about all the developers tools, okay, but now okay, let us come back come back and okay, put all these things in one place. Okay, so Hadoop cluster setup in real time. Okay, so this is the sample flow. Okay, this is the Hadoop cluster. This is what okay, they do, okay, with batch and real time processing. So normally these are the data sources. Your data source can be RDBMS, okay, log file, or okay, social media, or okay, IoT sensors. Okay, any of these things. Okay, so if this is a real time data, that will go through Flume or NiFi. If it is a batch data, that will go through Scoop. Okay, so when you go to NiFi, okay, NiFi can give it to Kafka. Okay, from Kafka, Storm will take, and okay, what Storm will list, Storm and Spark will take, and okay, finally they store the data into Hadoop cluster, and okay, reports can be generated here. Okay, and if it is a batch processing, so Scoop will extract the data and put in the STFS from here. Again, okay, MapReduce programs. Okay, maybe you will run some MapReduce, I MapReduce programs. Or okay, you may use okay. So when the data is pulled by Scoop, okay, on top of the data you can run some Spark research. Okay, and okay, so finally, okay, so whatever the data you processed, okay, either using okay real time or using batch processing, and now all the data is coming and sitting in the STFS. Okay, so from here okay, you can generate the queries here. SQL queries, okay, machine learning jobs. Okay, you can populate the dashboards. All these things. Understood? So this is the data source. Data ingestion is happening. Then okay, this is unprocessed data. Then okay, it is processing, transformation and processing happening here, and this is becoming a structured data. Okay, then okay, reports are being generated on the structured data here. Okay, so you take any project in the world, that can be fixed in this flow. That can be fit into this flow. Understood? You take any data in the any cluster, any Hadoop cluster, okay, in the world, okay, that can fit okay here. So only you have two things, okay, either batch processing or real time processing. Okay, so here okay, this tool is okay, this architecture is having batch tools and okay, real time tools also. Okay, but okay, nowadays okay, mostly people are showing very much interest on real time tools, not on batch tools. Got it? So slowly, okay, so maybe okay, in few days, okay, slowly all the batch tools may go out. Okay, only you will have okay, only you will have Hive, okay, which is like a data warehousing concept on top of Hadoop. So slowly, okay, so they want to make okay, they want to remove all the batch tools and okay, they want to make it like make this cluster like a lake house. Okay, all these days okay, we have data warehouse and okay, data lake. Okay, now they want to combine data lake and data warehouse together in one place. Okay, where they want to call it like a lake house. Okay, so maybe in future okay, lake houses will be implemented heavily. Okay, and this is the real-time cluster okay, batch processing, and okay, so this is the place. Okay, this is the Hadoop area. All the storage and processing will sit here. Okay, so you can see zookeepers, you can see resource managers, HBase masters. Okay, and name node, zkf, cisgender nodes, so all those things in this area. And when it comes to workers, okay, you can see data nodes, okay, and node managers, HRegion servers, Impala, okay, so those things can be seen in the Hadoop area. And this is the monitoring area, okay, so where you can see web UI, okay, so UI backend, RDBMS, all those things, and okay, you can see some kind of monitoring tools, Nagios and Ganglia, which we'll be talking about these tools in future. And okay, you can see the edge nodes here. So these are the edge nodes. Okay, on top of these edge nodes, you can install Scoop, Big, Hive, HBase. Okay, so it means okay. So this picture is talking about your real-time cluster without these tools. Okay, I'm talking about this. I'm talking about this one. Okay, so these are the, okay, if you are using only these without these tools, then okay, it is called as a batch cluster. Okay? So you will have only batch processing here. Okay, and now, okay, who will have access to what? Okay, suppose, okay, if there are applications connecting to Hadoop cluster, okay, will they connect through Hive, or sorry, will they connect to edge nodes, or okay, can application directly contact here? What do you mean of application contacting Hadoop cluster, guys? What is an application contacting Hadoop clusters? Huh? What is an application? You take your internet banking, guys. Okay, you open your internet banking in your laptop. Okay, and okay, you will click on account statement, and okay, you will click on, you will select the start date and end date, and you will click on show transactions. Okay, show data. Otherwise, okay, so you are sitting in Bangalore, and okay, you opened internet banking website from your laptop, and okay, you are selecting the last 1 month transactions. Okay, so will you be able to see your last 1 month transactions? Yes, right? Okay, now the question is that, okay, how this application is, okay, how your internet banking website is able to show that result. So internet banking website is directly connected to Hive server, which is running on edge nodes. So this is submitting a request to Hive server. Okay, Hive server 2. Hive server 2 is executing the query on this area and generating the report and sending back to your internet banking website. Now internet banking website is displaying on the screen. That is what is happening. Okay, it means, okay, if any external application want to use, or okay, you are swiping your credit card. Okay, so you will insert the credit card into swiping machine. Okay, so immediately, okay, the swiping machine will tell you whether it's a valid card, invalid card. Or let's say it is a valid card. So then it will ask you to enter the amount. Then it will ask you to enter the PIN code. Once you enter the amount and PIN code, okay, so it has to check, okay, the PIN code and okay, card number, okay, all these things are correct or not. How it will check? Immediately, the swiping machine will send a request to HBase script and ask, okay, hey, this is the credit card number, give me the details. Okay, now HBase script will give the details of the credit card number. Now, okay, it will compare whether the PIN and okay, card number and PIN are matching or not. If yes, then it will allow you to go to the next level or to complete the transaction. Got it? Okay. So applications will be able to. So there is no direct interaction between your application and okay, Hadoop area. So application will send requests to the tools okay, which are installed on edge nodes. So from here, okay, these tools will connect to the Hadoop area and get the data and send the result back to applications. Okay, and users, okay, are reporting tools. Okay, so users means okay, developers. Okay, so if developers want to connect, okay, they can connect to edge node only, and okay, they can run their queries. And if they want to connect any of the reporting tools, okay, yes, those reporting tools also will be connected, okay, in this area only. Okay, so for all these things there is no direct access, but when it comes to administrator, okay, so administrator can log into any of the machine in this cluster. Okay, so here, okay, mostly he'll be taking care of this cluster monitoring part, because okay, this is his main task. Hadoop administrator main task is making sure this entire cluster is up and running fine without any issues. Okay, making sure the entire cluster is green without any issues. Understood? Okay, So that's the reason. Okay, so mostly Hadoop administrator will be having okay access to accessing these services. It doesn't mean that a Hadoop administrator cannot log into its node or Hadoop administrator cannot log in Hadoop nodes. Hadoop admin is a person who can log into any of the node in the cluster. Got it? Okay. So this is the sample real-time cluster architecture with the batch processing, and okay, now you can see okay sample real-time architecture with batch and detail processing. Okay. So there is a batch and detail processing. Okay. So this is your Hadoop cluster where you have all Hadoop tools. Okay, you have Zookeeper, Impala, HDFS, Yarn, MapReduce, HBase, all those things. Okay. And okay, so this is the security area. Okay, so where okay you have okay LDAP and Cargos installed, but okay we didn't complete the security part till now. So when it comes to security part, I will talk about these tools. Okay, and now you know NiFi area. Okay, and you know Kafka area, and you know Storm area, you know Spark area, and you know monitoring area. Monitoring area means okay, it is the place where you can see your Ambari, where you install your Ambari nodes or Cloudera Manager, Nagios Ganglia tools. Okay. So here, okay, when it comes to search part, you will have Elasticsearch. When it comes to analytics, you will have Trino. And these are the edge nodes. Okay. So this is a cluster with the combination of batch tools and real-time tools. Okay. With this cluster, okay, you can do any kind of data processing in the world. Okay. And this cluster is having complete security involved, monitoring involved. Okay. Okay, so data, ingestion is involved. Okay, these two are data ingestion tools, data validation transformation tools, data processing or data dashboard tools, and okay, data search tools. Okay, so data accessing tools. Okay, so everything okay is in one place now. Okay, so normally if you join any company now as a Hadoop administrator, okay, you will see these things. You will see these things. Understand? This is the cluster you will see. Okay, but now sample real-time cluster architecture with application connectivity. Okay, so this is also very important case. What do you mean of application connectivity? Okay, so what is an application, guys? What is an application? Okay. What is an application? Can you give me some examples of applications? The internet banking website. Anything okay that connects to Hadoop cluster and get the data or store the data, that is called as an application. Okay. So internet banking website. Okay. Using this one, you can connect to Hadoop cluster and access your data, your banking data. Okay. Or okay. So swiping machine. This is also an application. Maybe okay, you will see it like a hardware machine, but actually when it comes to Hadoop, it is a swiping machine is an application. Okay. ATM is an application. Okay. So money deposit, CDM, okay, cash deposit machines, CDMs, cash deposit machines, okay, are some kind of applications. Okay. So hotels. So I'm just talking about the banking cluster bits. Okay. So any other banking websites. Okay. So these are all okay. All together are called as a application here. All these together are called as a okay, maybe Paytm. Okay, so Paytm. Okay, Google Pay. Okay. So these are all okay. So these are all okay. Will access the data from Hadoop cluster. So these are all called okay. So for Hadoop, okay. So all these comes under like a application here. Okay. So now, okay. Now this is about a banking cluster, and okay, these are the banking applications. Okay. So okay, let us take this one. Okay, I have a retail cluster. This is a banking cluster. Okay, so I have a retail cluster. What are the applications for this one, guys? Tell me. What are the applications for retail cluster? Can somebody give me some examples? let's say this is okay. So retail cluster. Okay, this is for Flipkart. It's a Flipkart cluster. Okay. So what are the applications that connects to this Hadoop cluster? Flipkart Hadoop cluster. Tell me. Huh? Tell me, guys. Guys, you there or not there? I'm just talking continuously.
Billing application, sir.
Sorry?
Billing application.
Billing application. Now, what do you mean billing application?
Transactions.
No. Okay. When I say retail cluster, okay. So what are the applications that will connect to this Flipkart cluster? Okay. So website.
Wallets. Wallets.
Websites. Okay. Website. Okay. Flipkart wallets. Okay. Flipkart. Okay. App. Flipkart app. Okay. Anything else? Anything else, guys? Okay. Anything else? Okay. At this moment, okay, you take, okay, so these are the different ways, okay, the different applications which will connect to, okay, so merchant websites, okay, so here, okay, so okay, so if you're a merchant, okay, so you will have, okay, you will have a tie-up with Flipkart, okay, so merchant means, okay, if you want to onboard your items, you want to display your items in Flipkart website, okay, you can actually, okay, that's a merchant website, okay, so majorly these are the okay, these are the different applications, okay, normally people will use, okay, so now, okay, so this is, okay, let us take this one, Flipkart internet website, okay, so how this website will be created here, okay, so legacy application, legacy model of internet website. So if you see the legacy model of internet website, okay, so normally what you will have, so you'll have a server here. Okay, so okay, you take like this case, okay, so this will give you more clarity, okay. So ATMs, hardware, software, okay, so banks, okay, mobile applications, okay. So these are the different applications will be connecting to banking clusters. Okay, connecting to, okay, this is the banking, this is the real-time cluster of HDFC Bank, okay. So it contains all these things now, okay. So suppose, okay, so this is the website. This is the website here. Okay, so maybe, okay, so okay, this is a physical server. Okay, this is your internet banking website. Okay, this is a physical server. Okay, so this will have a backend RDBMS. Okay, and OS is installed here, and internet banking software is installed here, and okay, you will have a web server. Okay, so normally, so whenever, okay, you request, okay, let's say, how do you access this one? Okay, so normally what you will do, so Venkata here, okay, you open the Google Chrome. Okay, so Google Chrome, and here, okay, so you will open HDFC net banking. Okay, you type this this user ID and password. Okay, this is sorry. He'll type this URL from Chrome. Okay, so immediately it is showing this page. From where this is showing these pages. Okay, so this is the place where there is a server with this one. What to say? Okay, by hosting this internet banking software. So when okay, Venkata try to access this link. So what it will do over internet, it will connect to this server application server. So this is called as application. Application. Okay, so the request will hit this URL and access the web pages here. Okay, and based on the selection you do here, okay, so immediately this web page this internet banking website, okay, a software will connect to any of these required nodes and get the data and show it on the screen. So normally, so this is how, okay, this is how your data will come and sit inside the Hadoop cluster. But okay, this is how you will be seeing your data. This is how you will be seeing your data. Okay, so these are the different ways, okay, where transactions can be. Okay, ATM. Okay, you can withdraw money. Okay, if you withdraw money, again there will be a transaction here. Bank, if you directly go to bank also, you can deposit money, you can withdraw money, transaction will be here. Mobile applications, using mobile application, you can deposit, withdraw, transfer. Okay, so not withdraw, okay, you can transfer, you can do online transfer, NEFT, IMPS. If you do anything, okay, the data will come and sit here. Okay, Phone Pay, Google Pay, payment gateways, okay, swiping machines, internet banking. Okay, so by using all these things, okay, you can generate some transactional data. Okay, the transactional data will come and sit inside this Hadoop cluster. Okay, now if you want to see this transactional data, so okay, maybe this is in HDFC Bank. Okay, this is in Mumbai. Okay, and maybe this is also internet banking website. Okay, it's also hosted in Mumbai. Okay, so now, okay, so Venkata is on his laptop in Bangalore. So now when you connect, okay, from here, if you connect, so the first, okay, it will connect to the website. Okay, from here it will, okay, from here or this website, we will have direct connectivity to the cluster and get the data and show it on your screen. Okay, so this is how a traditional application will work, guys. This is how a traditional application will work. Understood? Okay. Also, okay, it is the same case of even for Flipkart also, right? It is the same case for Flipkart also. Okay. So think that, okay, so this website can handle, okay, 100 users at a time, 1,000 users at a time. That means, okay, 1,000 people connect to this internet website. Okay, so this website will run without any issues. Okay, but later, okay, so suppose what in case, okay, if I have more than 1,000 users connecting to this website, so you will see, okay, at times, okay, the internet website is down. Okay, now one of the best example is IRCTC. Okay, so during that time, okay, it will go down. Even after entering all the details, also it will say page expired or page can be displayed. You'll be seeing this kind of errors. Do you know why? Okay, it means, okay, there is a too much load.
Maximum.
Too much load on this application. Okay, so how to handle the load? Too much load. If I have only one application that supports 1,000 users, okay, then okay, if there are many customers trying to access this this internet website, obviously it will go down. Correct or not? So it is a big headache to the application owner, okay, or the application support person. Okay, so to restart this application every time. Okay, so to avoid this one, what they have done? Okay, so come up with a different load balancer concept. Okay, so what they have done? Okay, so they started. This is physical server 1. Okay, this is physical server 2. So they have taken two servers. Okay, they build like this actually. Okay, this is server 1, server 2, and okay, so here again there is a load balancer. Okay, so this okay, this is the load balancer here. Okay, so normally now in this scenario, what will happen? Okay, if Venkata, okay, from Bangalore, if we try to connect here. So now, okay, it's not okay. In the earlier scenario, it's in the legacy model. Okay, so Venkata is directly hitting the internet banking application, but now Venkata is hitting, okay, the load balancer. Okay, now the load balancer is the one who will see is the load. Okay, so who is having less load, and okay, forward it to the respective server. Okay, this is another model, okay, where we have. Okay, so this is the another model. Guys, okay, I'm just explaining about your application. Okay, so okay, at the end, okay, what I'm trying to do here, okay, so I'm trying to give you a small introduction about your Docker and Kubernetes. Okay, initially you had an application. Okay, you have an application. Okay, so you used to directly contact this application. Okay, this is the internet website you used to contact. Okay, but whenever there is a payload, this internet website used to go down. Okay, but later, okay, they changed this application model like this. Okay, so they started introducing. They introduced, okay, to like this. So whenever, okay, any user started accessing this website, okay, so here, okay, they put a load balancer and they started routing the traffic here. Okay, so in this scenario, this will handle 1,000 users and this will handle 1,000 users. Okay. So with the help of this architecture, so how many you can handle now? You can handle 2,000 users. 2,000 users. Okay, but what in case, okay, if the customers are more? Okay, if more than 2,000 customers, okay, what you can do? Okay, here can use to put a common database between these two. Okay, so maybe it's here. Okay, so this is what they done. Okay, so when it comes to the next part, okay, but later what happened? Okay, so okay, this is okay, but this is not so effective because what in case if I have more than 1,000 users? Okay, then what they've done, they come to this concept here. Okay, users. This is the concept they come up with. Okay. So these are the users. Okay. So now, okay, but here when it comes to users, okay. So here, okay, when it comes to users, okay, so like this actually. Okay, so okay. So now, okay, if you see that, okay, you have too much load, let's say, okay, you have too much load. Okay. You have 5,000 users. Okay, you have 5,000 users. Okay, so to handle 10,000 users, to handle this 10,000 users, okay, so two are not sufficient. So what they have done, they come up with a multiple physical server concepts actually. Okay, so each server can handle, okay, 1,000 like this actually. Okay, so each server can handle 1,000 requests. Okay, but do you think, okay, so at the peak hours only can we have needed if I have 10,000 requests, okay, 10,000 people connecting. So night 12 to 6, okay, maybe very less people will connect to this URL. Morning 6 a.m. to 9 a.m., very less people. But 9 a.m. to 6 a.m., this is the business hours. So this is the peak time, okay? So where okay, you will have more load, okay? So morning 9 to 6 okay, only you require 7,000. Okay, so all the 7 servers, okay, which can each server can handle one. Okay, so all these applications, okay, all these application server will be in use only during the 9 a.m. to business hours time. Okay, 9 a.m. to 6 p.m. Okay, but rest of the times, yes, okay, we have the request, okay, but okay, not so many. Okay, say 9 12 to 6, okay, only 500 people connected. 6 a.m. to 9 a.m. okay, 1200 people. Okay, 6 p.m. to 12 a.m. okay, 1300 people. Okay, so now, okay, see here, okay, you are using okay, physical servers, and okay, you deployed application in 7 servers, and okay, you are allowing your users to connect to this okay, connect to any one of the server, and okay, you are making sure that okay, the internet website is up and running for the users. Okay, but are we effectively utilizing these 7 physical servers? So if you see here, okay, only 38% of the time, okay, all the 7 servers are used. The remaining 63% of the time, they are ideal. See, only 9 a.m. to 6 p.m. time, okay, all the 7 servers are in use. Remaining time, if I have only 2, okay, so see, for this one, for 12 a.m. to 6 a.m., I'll have only 500 requests, so 1 server is sufficient for me. Okay, 6 a.m. to 9 a.m., so 1200 requests, okay, if I have 2 servers, that is sufficient. Okay, but okay, 6 p.m. to 12 a.m. also, if you have 2 servers, that is sufficient. Okay, so in this scenario, we are not utilizing our servers, okay, efficiently or effectively. So only 38% of the time, all 7 servers are up and running, but remaining time, okay, so 63% of the time, okay, they are not in use. Okay, so this is one drawback if we go with the physical server model. Okay, so to avoid this one, what they have come up. Okay, so now, okay, so they have come up with the virtual machine concepts. Instead of physical servers, they have come up with a virtual machine concept base. Okay, in the same physical server place, okay, so they come up with a virtual machine. Okay, so what they started doing, okay, so they started doing with okay, introducing virtual machine, and okay, manually, whenever there is a load, they are increasing. Whenever there is no load, they are decreasing, stopping the VM. Okay, they used to do this one. Okay, so they created virtual machines for each application. So whenever there is a load, suppose, okay, if there are 7,000 people trying to connect, okay, they are switching on all the 7 virtual machines. So if there is no load, they are switching off the machines, okay, switching off the machines, or virtual machines. Okay, so this is how they started managing in the later stages. See guys, okay, with one machine, where it started with one internet web server, and then it has come 2, then it has come many with physical servers. Okay, then okay, physical servers are replaced with virtual machines. Okay, but here also there is a manual work. This is good. Okay, but okay, there is a manual work. Okay, you need to stop the virtual machines. Okay, so to avoid this one, okay, so what they have done, they came up with a new concept like this. Okay, so this is the concept. Okay. This is the concept, guys. Okay, they have something called Kubernetes cluster. Okay, so they have the Docker page. Okay. What they used to do? So they used to, so Kubernetes is a kind of a cluster where it can launch the containers. Okay, so now here, okay, okay, what they have done here, okay, so they started loading the containers here. Actually. Okay, what do you mean of container? It's a place, okay, where your web server is hosted or web application is hosted. Okay, so here, okay, all these containers are using same OS. Okay, so it's kind of okay, lightweight containers actually. Okay, so what they used to do, okay, whatever the application you want to host in the container, they write everything in the Docker page. Okay, and they tell, okay, so here it is the automated way of adding and deleting the containers. So they say that, okay, Whenever there is a high load, add one container. Whenever there is a less load, okay, reduce one container. So with the help of Docker and Kubernetes, okay, this application deployment and management has become very, very easy. Okay, so that okay, whenever there is a load, okay, Kubernetes cluster will automatically add okay one container. So that okay, that container can handle extra 1,000 people. So still load is more. Okay, so still it will add one more container. Okay, so like this, okay, you can tell okay, what are the minimum containers you want, what are the maximum containers you want. So if you say minimum containers 2 and maximum containers 7, or minimum container 1 and maximum container 7. Okay, so whenever there is a load, it will increase to max of 7. Whenever there is a less load, it will reduce to one container. Okay, so again, this is completely automatic process, and okay, this is 100% effective utilization. What do you mean 100% effective utilization? Okay, so nowhere the resources are getting wasted here. Nowhere the resources are getting wasted. Here. So here also the physical servers are getting wasted. Here also virtual machine, okay, somehow it is better when compared to physical server. You're using virtual machine, you're stopping those virtual machines. But okay, these are dedicated virtual machines. Okay, but here, so whenever you want, you spin up a container and okay, start a web service okay, inside that. Okay, and okay, that will be part of that will start okay, that will be part of the load balancer, and okay, your more queries you are getting, and okay, it means okay, so more containers will run, and okay, they all will share the load actually. Okay, so that's how the applications okay, started deploying. And so here okay, in application deployment, Docker and Kubernetes are playing major role nowadays. Clear? So if you see the legacy model, okay, how okay, they started with okay, one physical server on one application. Okay, one software is hosted on one your banking application hosted on one physical server. Okay. Later they come up with the load balancer and 2 physical servers. Then okay, multiple physical servers. Okay. Then they remove physical servers and okay, they replace those physical servers with virtual machines. Okay. So then okay, so these virtual machines also they replaced with containers. So now this is the current trend of the industry. Any internet any application you want to host, okay, you will host in containers. Okay, so these containers will have the what is it? Auto elasticity. Okay, like whenever there is a load, okay, they will add this Kubernetes cluster will automatically add a container, and whenever there is no load, okay, it will automatically reduce the containers. Okay, so this is not Hadoop concept, but okay, I'm just giving you an overview, guys. Okay, so this is what okay here. So Docker, Kubernetes, okay, we have used these symbols, right? Okay, so that's the reason I explained so much here. Got it? Okay. So this is how the applications will connect to your cluster and access the data. Okay. But okay, so normally if you see the Hadoop cluster, guys, what is export to end users? As an end user, will you directly access Hadoop cluster of HDFC Bank? No. Okay. So if you want to access the cluster of HDFC Bank, okay, you need to have a application, maybe your internet banking website. Using your internet banking website, if you select some of the options, that website will connect to Hadoop cluster and get the data and show it on the screen. Got it? Okay. Got it or any questions? Okay. So this is about okay real-time cluster, and now okay, so we have okay, one question okay I've seen okay in interview like okay, give me the components that has high availability in your cluster. So where and all okay, we are using multiple services. Zookeeper, okay. So how many Zookeepers we are using? 3 Zookeepers. Okay? In real-time clusters, they use 5 Zookeepers or 7 Zookeepers max. Okay, 7. Okay, but odd number. Okay, is it HA or okay, LB? What is the difference between HA and LB? HA means okay, active standby concept, guys. Okay, you have active zookeeper. Okay, so you have a leader zookeeper and the remaining handle follower zookeepers. If leader is down, any follower will become leader. Okay, and journal nodes. That's also HA concept only. Name node. So you'll have active name node, standby name nodes. If active is down, any standby will become active. Resource manager. This is also HA. Okay. So resource manager HA means okay, you will have active resource manager. If active resource manager is down, standby resource manager will take care of the work. Okay. And MR job history server. This is also HA. Okay. Hive server 2. It is a LB. What do you mean of Hive server to LB? What do you mean of Hive server to LB? Okay. Suppose okay. So okay, I'll tell you the difference between HA and LB. Okay. This is the difference. Okay, you can see here. Okay. Let's say if it is HA, okay, you have a okay name node. Okay, we'll take NN1, NN2, okay, and NN3. Okay. So this is the active name node, standby. Okay. If there are 100 requests, okay, there are 100 requests. Okay. In case of HA, all 100 requests will be routed to active name node only. Understood? All 100 requests will be routed to active name node only. Okay, this is HA part. Okay, this is HA part. Okay, but okay, what is LB here? Okay, so we say LB for Hive server 2. We say LB for Hive server 2. Okay. Okay, so here there are 100 requests, maybe 33 requests. Okay, it is like all are active. Okay, 33 requests will be handled by this HS2, 33 will be handled by this HS2, 34 will be handled by this HS2. So this comes under LB, load balancer. Got it? Or any questions? You understood the difference between LB and HA?
Yes,
HA means okay, all 100 requests will go to the active one only. Okay, LB means okay, so the request, okay, if you have 100 requests, all 100 requests will be shared by existing, okay, all existing Hive server 2s. Okay, so here okay, I have told you okay, what is LB and what is HA. Hive Metastore service, it is LB. HBase master HA, Flume agents HA, Spark History server HA. So MySQL database okay, which are okay, used for Cloudera Manager, Ambari, Hive, Oozie, these are also HA. But okay, you can set up this like active or active standby also. Okay, so but these are the components. Okay, so which has HA or LB. Okay, so in interview people may ask, okay, Zookeeper is HA or LB. Okay, you should have okay clear idea like whether it is LB or HA. Okay, so these are the different components that has high availability. Okay, and guys, this is one slide where you need to buy hat. Okay, suppose okay, if you say that okay, you are a real-time employee, definitely okay, in some of the interviews they will ask okay, which Cloudera version you are using, which Hortonworks version you are using, which CDP version you are using. Okay, so as you know that again, in case of Cloudera, the UI version and stack version both are same, but in case of Hortonworks, it is not the same. In case of Hortonworks, Ambari version is different and stack version is different. Okay, and in CDP also normally UI version and stack version both are same, but in the latest versions, okay, they are giving different okay, UI version and different stack version. Okay, so you need to buy hat. Okay, if you tell okay, you are using old Cloudera, if they ask okay, you can tell you are using 6.1.1. Okay, and again okay, operating system, which operating system you are using, RHEL or CentOS. It's not and okay, so you can tell okay, either RHEL or you can tell CentOS. Okay, and again okay, so MySQL, which MySQL you are using, you can tell 5.7. Okay, then okay, which Java version you are using, Java 1.8. Okay, and these are okay, these are the different components in the stack. Okay, which one we are using, we can talk about this. And this is the table we need to buy hat. There is no other go. Got it? Got it? Or any questions?
As part of that, interviewer perspective, currently which distribution you are working? Question.
Sir, okay, you can tell. Okay, so you can tell old Cloudera. Nobody will say no for that. Okay, because okay, so you are still using old Cloudera and slowly you are migrating to new Cloudera. Okay, okay, you are using Hortonworks. Okay, you are migrating to new Cloudera. So that is also possible, right? Okay, you tell that okay, directly new Cloudera only, CDP only. Anything is fine.
Okay. Hortonworks, suppose Hortonworks is
Still there in the market, okay? Because okay, not all the people, all the customers can migrate to CDP. Okay, still okay, because of this corona, actually, okay, they are supposed to complete by 2021 itself, actually. Okay, but because of this corona, okay, Hortonworks has still extended their support. Okay, it means okay, sir, okay, currently I'm working on Hortonworks cluster. It is there and it will be there for next 6 months. Maybe by end of this year, okay, we will decommission Hortonworks. Okay, we're almost okay done with the migration to CDP. Okay, we are migrating to a new CDP version actually. Okay, but however, okay, so we are still using Hortonworks clusters also. Got it?
yes. Thank you.
And you need to by hand this page. There is no other go. Okay. So with this, okay, so one more module is completed. Okay, so ecosystem tools module is completed. The next module is Hadoop cluster upgrade. Okay, so what is this Hadoop cluster upgrade? Okay, so now so we are using. So let us take this one, upgrades. Okay, so currently which version of Hortonworks we are using? Okay, so anything actually. Okay, let us check. Since we are using Hortonworks, okay, I'll show you Hortonworks. But I'll give you the document for both Cloudera and Hortonworks. But okay, we'll see. Okay. Okay, so now if you see about so what is the version of Ambari we are using is 2.7.3. Okay, so Ambari version is 2.7.3. This is the version that we are using. Okay, and which version of Stack we are using? Okay, so this is 3.1.0 Hadoop Stack. So here UI version is different and Stack version is different. Okay? But at times, okay, we may have to upgrade your clusters. Yes or no? So upgrade your clusters to the next version. They may ask you, or okay, let's say you are using a Cloudera Manager. Cloudera Manager again 6.1.1. Okay. So then okay, Hadoop Stack, Cloudera Stack. Okay, same one. Okay. Now your company may ask you to upgrade this to 6.3.1 or 6.3.2. Okay. They may ask you like 2.7.6.0. Okay. 6.0. Okay. Okay. 3.1.4.0. Okay. So it means okay. Every time, okay, whenever there is a requirement, okay, so you may have to upgrade your Hadoop cluster. Okay, so when you're upgrading your Hadoop cluster, what are the different things you need to keep in mind? Okay, in interview, they may ask you guys, they may ask you these steps actually. Okay, at the high level, they may ask you. Okay, but however, okay, we will see. Okay, so today, okay, this is the current version. Okay, I want to upgrade to the next level. Okay, so next level. Okay. So what I will do, obviously, if I want to upgrade, okay, so here, guys, okay, I have given. Hortonworks upgrade also I have given and Cloudera upgrade also I have given. Okay, Cloudera upgrade also I have given. So I'll give you CDP upgrade also maybe sometime. Okay, so I got the latest parcels, guys. Okay, so luckily, okay. So if you see this one, stuff 2. Okay, Cloudera, I got the latest parcels. This is the latest. The last release version of Cloudera. Okay, luckily I got all the softwares from one of my known person. Because okay, this if you want to download these things, okay, that require a license, correct? Okay, license, okay, that will cost you too much money. Okay, but okay, so I've taken that guy help. Okay, and okay, got all these softwares. So maybe okay, in the next batch, okay, I will show you the latest version of CDP and all because okay, they have very good. Okay, so they have very good options in the new version of CDP. New release, they have added multiple tools. Okay, so maybe from next batch, okay, I will completely show everything on CDP only because okay, everybody will be working on CDP. Okay, but till now, okay. So learning in Hortonworks also fine. Okay, but okay, next batch definitely I will cover everything in CDP. Okay, even all the tools also I'll cover in CDP only. Okay. Now, what is our idea? Since okay, we are using Hortonworks, okay, so we have 3.1.0 and we want to migrate it to 3.1.4. Okay, so what we will do now? So cluster upgrade. Cluster upgrade is required whenever you want to move from older version of Hadoop to newer version of Hadoop. Okay, so here I'm saying Hadoop 2.7.3. What is this 2? What is 7? What is 3, guys? So 2 is a major version, and 7 is a minor version, and 3 is a maintenance version. Okay. Normally, if you see the major version, okay, they will change it every once in 2 years normally. Okay, 12 to 18 months, or okay 18 to 24 months. Okay, but okay, minor versions okay will normally change every 3 to 4 months. And maintenance versions whenever okay they fix the bugs. Okay, whenever they want to release the new version, okay, they release the maintenance one. Okay, so today they may release 7.3 by today morning. By evening they may release 2.7.4 also, because okay 2.7 they have bugs. Okay, so they release 2.7.4. Okay, it is like that. So now when it comes to updates, there are two types of updates, guys. One is express upgrade. One is express upgrade. The other one is rolling upgrade. Okay, so what is the difference between these two? When it comes to express upgrade, okay, you will stop all the clusters, stop all the web services, okay, radio cluster, so this is the express upgrade. Okay, you stop all the Hadoop services on all Hadoop nodes and upgrade the Hadoop services on all Hadoop nodes and start Hadoop service on all Hadoop nodes. It means okay. So suppose okay, you stop this all entire cluster at 7:30. Okay. So to upgrade, okay, it is taking okay till 8:30. You completed okay till 8:30. Completed upgrade. Okay. So 8:35 you start the cluster. Okay, 8:40 you started the cluster. Okay. It means okay. So from 7:30 to okay 8:40 is the downtime or not? Huh? So it means okay, entire cluster will be down. All the nodes, all the services are down. Understood? All the services are down. All the what is it? Not all the nodes, okay, but all the services, Hadoop services are down. Okay, so you cannot use any of the okay, nobody run any jobs okay this time. But when it comes to rolling upgrade, okay, stop all the Hadoop services on one node, one Hadoop node, upgrade all Hadoop services on one Hadoop node, and start all the services on one Hadoop. Okay. Okay. Now you see, guys, what we are trying to do here. Okay, we are stopping all the Hadoop nodes in the cluster. In the cluster. Okay, all Hadoop services on all Hadoop nodes in the cluster. Okay, upgrade all and start all. Okay, so here there is a downtime. Okay. But when it comes to rolling updating the cluster one node by node. Okay, I will update the, suppose if we have, okay, 4 name nodes. First I'll update one name node. So when this is getting updated, okay, other 3 will be in use. Okay. So okay, once okay, update is done, okay, I will start this one. Then okay, I will take the second node down, okay, update the cluster and update the node and start the services. Okay. So it means okay, if I stop and start okay, one name node, okay, even if I stop one name node, okay, the rest of the name nodes will be working, right? The same case, if I stop one data node, okay, rest of the data nodes will be working. Okay. So in case of rolling update, okay, this may take time, but okay, no downtime at all. Repeat about 3 steps. For all nodes in the cluster. Understood. Repeat about 3 steps. Okay. All the nodes in the cluster. Okay. So this is called as a rolling update. Okay. Normally, what kind of update they do in real time?
Rolling one, sir.
Rolling one is the one. Okay. See, if their cluster is critical cluster, okay, they will go with the rolling one. Okay. If customers are okay to stop the cluster for 1 hour, okay, they'll go with the express one. It's up to them. Okay. So now I will practically show you how to upgrade the cluster. So I guess okay, we have 28 minutes. I guess this time is sufficient to see the upgrade. Okay. So now I will open the upgrade document. Let's upgrade. As a first step, what we need to do. Okay. So what are the prerequisites? Ensure all the services are up and running in the cluster without any issues. Okay. Now go to Ambari and make sure okay, all the services are up and running without any issues. Okay. Here there are some alerts. What is this alert? Total blocks, missing blocks. Okay. About a day. Okay. This is fine. Okay. And any other issues? Connection failed. Why? Okay, that is fine. Okay, not at all a problem. Okay. So here, okay. So make sure all the services are up and running here. And okay, clear all the alerts if they okay, and okay, remediate. Okay, clear all the alerts or understand why they are being generated, and remediate as necessary. Okay, if it is required. Okay, so. Okay, close those. Okay, resolve those issues. Actually, resolve those alerts. Okay, and run each service check. Okay, so I'm found under service action menu. Okay, so this can be done later. This step can be done during upgrade. Okay, then get all custom jars from tools like Scoop and Hive. Okay, what even of custom jars is? Let's say okay, you are using Scoop to extract data from Teradata. Okay, so when you install Scoop, okay, will Teradata jar come automatically, or you will be installing Teradata jar separately? You will install Teradata jar separately. Okay, so when you install any custom jars, okay, like that. Okay, so please get all the custom jars. Okay. Okay, please take a backup of all the custom jars because okay, you need to put all the custom jars in the new version of Hadoop cluster okay, once upgrade is completed. Okay, and make a note of any nodes services scripts to bring down okay, bring up before upgrade. Okay, so when scripts are running, suppose okay, you schedule some jobs to run continuously. So if you have okay, such kind of okay, scheduled jobs or okay, any scripts you are running, okay, please stop them. Okay, but until the upgrade is completed, and make sure you have enough space on the RPM directory for the new HTTP RPMs. Okay, yes. So we have taken care of all these things. Okay, first thing at the time of upgrade process. Okay, what we need to do, guys? Okay, so we need to send a communication mail to all the developers, business, or application users about the downtime window. So we need to send a communication mail to all the people saying that okay, on Saturday from this time to this time we are upgrading our cluster. So please, I mean, you can expect okay, some failures. Okay, so during this time, okay, some service downtime. Okay, during this time, Please bear with me. Okay. Suppose okay, if you don't send the communication to the users, okay. So they think that okay, the cluster is okay. When you're upgrading, okay, if you stop entire cluster, at the same time, okay, those developers are trying to access the cluster, it will not work. So that will be a problem. Okay, so that is the reason. Okay, you should send a communication, official communication mail to all the developers and the business or application users about the downtime. You might have seen this kind of messages, okay, from banks, okay, like okay, our systems are getting updated from this time to this time and so on so date. Okay, during this time these services may not be available, like that. Okay, in the same way for cluster upgrade also you need to send a communication mail. Okay, then put all your problematic nodes into maintenance mode. Okay, if you have any problematic nodes, okay, you put them into maintenance mode. After that, okay, so create a backup directory. So what I'm doing, okay, so I'm logging into HA machine and I'm creating a backup directory, upgrade backups in all the nodes. Okay, so here now what I'm doing, I'm just saying that, okay, so I'm putting my name nodes into safe mode and I'm doing the checkpoint. So better to perform checkpoint before we start the update. Once checkpoint is completed, the backup of this one, FSCK. So what is FSCK command? This FSCK command will list all the files, blocks, locations, and tracks. Okay, so take a backup of this one. Okay, even DFS admin report. Okay, so these reports are very helpful to cross check. Okay, after upgrade is completed. Okay, so before upgrade is completed, there are 10 data nodes. After upgrade, okay, there are only 9 data nodes. It's a problem, right? So to cross check, okay, you will be using these reports and get all the files report. Okay. Normally at times, okay, developers will come and say that okay, before upgrade, okay, I had 10 files. Okay, after upgrade, okay, we have only 9 files. One file got deleted. Why upgrade will delete a file? So to be safer side, okay, you take all the list of all the files report, can keep it ready. So tomorrow, if somebody come and ask, okay, after upgrade, okay, this file is deleted, that file is deleted, okay, you can still show this report. Okay, so take the screenshot of Ambari name node IVN for future reference. Okay, and okay, take the backup of MySQL database. Okay, the backend UI Ambari backend database backup and take. Okay, done. Okay, so then okay, even okay, first image edit log copies also I'm taking one backup. Okay, because okay, tomorrow, okay, so during update if something went wrong, it's the problem. Okay, that is the reason better to take a backup of FS image files. Okay, edit log files. Okay, understand? Okay, so edit logs and all. Okay. After that, okay, so take a data node version file. Okay, so if you take one version file, that is fine, but however, okay, you take a version file. Okay, then okay, zookeeper backup also. So Jetcadet, MNTD3 Jetcadet also you take a backup. Yes. Okay. So I have taken the name node metadata backup. Okay. Then okay, zookeeper metadata backup. Wherever okay, metadata backups are there, okay, so I've taken backup of all those things. Okay. Now I'm stopping the Ambari server and Ambari agents. Now I'm stopping Ambari server and Ambari agents. Okay. If I stop Ambari server, okay, now you see the UI will not work. But okay, whatever the cluster is, will the cluster be still working? Now if I say SDFS, DFS-LS, is it still working? It is still working, right? Okay. So it means okay, if a UI is stopped, okay, it doesn't mean that a cluster is stopped. Okay. If you see Hadoop cluster, okay, in Apache Hadoop, okay, you will not have UI, you will have only Hadoop cluster. So UI is a place okay, where okay, you see the current status of the cluster. Okay, but if you stop UI, it doesn't mean that okay, your Hadoop cluster will be stopped. Now my Hadoop cluster is still up and running only. Okay. So anyway, we are not using Windows mode. Okay, and you need to download all these RPMs. Okay, so anyway, I downloaded. You download it from Google, from this one. What to say? You download this from Stuff2, and you can copy to HA machine via www.html. Okay. Now I've already done this one. It is not there. Not on HN1. Okay. You know, I have downloaded all Autonomous 3.1.4 version. So now, see inside this one, what is there? There are 4 files. Okay. Extract these things. Now I'm extracting the Hadoop software. Okay, I mean entire Hortonworks UI software and Hadoop Stack software, everything. See here all the binaries of 3.1.4 here, 3.1.4.0. So the first step, I'm extracting the Hadoop software in the UI machine. Yeah. Okay, it got extracted now. Fine. So now what I will do, I will delete all the repos. Okay. If I have any repo files, I'm moving it to, I'm removing all the existing Ambari repo files. Yes. Okay. Remove. Now I'm creating a new repo file, Ambari repo file. Okay. So here it is pointed to 121 machine. And this is the 3.1.4 version. Like this, okay. You remember, okay, we need to create total four repo files. One for UI, another one HTTP stack, one for GPL, one for utilities. Okay. These are the things, okay, which we started. Okay, so now now you can see Ambari repo and okay, HTTP repos are there. Okay. Now say yum-list Ambari server. Yeah, okay. So it is saying that okay, so already 2.7.3 version is there, but okay, new package is available 2.7.4. Okay. Now you upgrade the server. Upgrade the server. Okay. Let it get upgraded, guys. Okay, but okay, meanwhile, okay, we will see what is happening here. Okay, so here I have HN4, okay, HAM, HN1, HN2, HN3, HN4. These are the 4 machines. So here, okay, I installed Ambari server. So here Ambari agent. Here, okay. Then okay, so I've installed HDFS service here. HDFS. Okay. Installed Yarn. Okay, installed Tej. I installed Scoop. Hive. Okay. HBase. Then okay. Kafka, Spark. Spark. Okay, so an Ambari matrix. Okay, so these are the things. Okay, so where can we installed? Okay, so maybe okay, it's CFS. Okay, so it's one of the HDFS service is installed. Okay, like this. Okay, so this is your cluster. Okay, now first what I'm doing, I'm updating this cluster. Okay, so updating the server first. So server is updated. Okay, yes, it is updated to 2.7.4. Okay, once it is updated, now you need to, so how to validate whether it is updated or not. Okay, so you need to execute this command. Okay, so this will tell you what is the new version of Ambari server we have. It is 2.7.4, not 2.7.3. Okay, now okay, you need to update, you need to execute the update. Okay, so confirm you have made a backup of Ambari server database. Yes. Okay, updating the database schema also. Yes, it is upgrade completed successfully. Okay, so now okay, upgrade all the agents actually. Okay, so we stop the agents, right? Okay, so we put the RPM files or I mean repo files to all other nodes. Okay, yes, okay. Now upgrade the agent. We are upgrading the agents. Means okay, I'm updating the agents also now. Okay. Yes, in all the nodes, okay, all nodes, okay, got updated. Now, okay, just to confirm, grep Ambari agent. It should be 2.7.4 in all the nodes. Yes, in all the 4 nodes, okay, it is 2.7.4. Yes. Okay, and okay, disable this GPL license. Okay, so now I'm starting the Ambari server. Start the Ambari server. And then I can start the agents also. Yes, start the agents also. Okay, I started server and I started agents also, so everything is fine. Now, okay, these are all completed, successfully completed and started also. Okay, now you just say refresh. Okay, now go admin. Okay, all this time the summary is not there, but still Hadoop cluster is up and running or not? Yes, all are real. Okay, and now you see the about version, it is 2.7.4. So UI is upgraded successfully. There is no problem at all. Okay, so now start the cluster services. Okay, so here okay, this is fine. Yes. Okay, so now what I'm doing here, first thing, okay, go to admin manage Ambari versions. Admin manage Ambari versions. Click on versions. Okay, so here okay, currently it is 3.1.0, it is running. I want to make it 3.1.4. So click on register version. Okay, so 3.1.4.0 here. Okay, then okay, you need to click on local repository and you need to remove everything except Red Hat 7. So here you need to provide the URLs. Okay, so HTTP1 URL is this one. This is HTTP1 URL. This is HTTP GPL URL. and this is utilities URL. Click on save. Okay, now you have 3.1.4. Now click on install on MyDev cluster. Okay, now you can see the difference. Okay, this is 3.1.0, this is HTTP 3.1.4. Okay, so now click on install packages. Yes, now it is installing all the new versions. Here.
So what is that MyDev cluster you have? Is the same node set of nodes on the right?
Sorry,
What is that MyDev cluster where you click the
it's
button?
the name of the cluster I have given, sir.
Oh.
So now you can see the installation status here.
So in case individual ecosystem tools we can't
You want to
develop.
upgrade? No, you cannot upgrade individual ecosystem tools. If you want to upgrade it, you should upgrade entire stack.
So the same for CDP also, sir?
Yes, sir. Yes.
So we cannot upgrade the echo tools for the individual, right?
Yes, sir.
So if we need to change total cluster, we need to
Total
upgrade.
cluster only when it comes to upgrade. Now it is installing all the new tools actually. Okay. I don't know how much time it takes this. I thought it will be completed by 9 or 9:10 max, but okay. Let's see.
Sir, I have one doubt.
Yes, sir. Yes.
Whether in the case of Ambari or whether in the case of this Hortonworks or Cloudera, so generally when you started the installation of this Hadoop nodes and all, you showed a process of shutting down and bringing up the cluster. So in the similar way, for if you are going through Hortonworks or CDP, so how do we if you have to bring down the cluster? Okay.
You stop entire cluster, sir. Okay. Here, did I stop entire cluster? First of all, tell me. My cluster is still running with green only. Can you see this one?
Yes. I know. I've seen that option. But that is the way only you have to do that to bring down the entire cluster and then shut down all this.
No, sir. No. It's not like that. Okay. See, it's purely depends actually. Okay. It's purely depends. Okay. How you install. Suppose okay, your cluster is okay to have some downtime. Then okay, go ahead with okay, shut down all the services and okay, upgrade the cluster and okay, restart the cluster. I'll give you one example also, sir. Okay. So normally, okay, so I work for a banking client. Okay. So our production cluster is very, very important, right? So we can I stop a banking cluster, production cluster?
No.
Banking.
No.
Production cluster. No. Okay. But okay, can I stop the banking cluster, UAT cluster? Banking.
Yes.
UAT.
Yes.
UAT, no direct interaction with customers, right? Okay, I can stop. Correct.
Okay. Yes.
Okay. So we need the UAT cluster as a express upgrade and production cluster as a rolling upgrade.
Okay. So if I'm doing my lab like in my laptop, so if I just stop all services and then I can bring down all the servers randomly,
yes,
right?
Sir. Yes. Don't bring down all the servers. Okay. If you stop all the servers, where upgrades will happen.
No, not in terms of upgrade. I'm saying in case if I'm having a lab like I'm doing in my laptop, so I can stop all the services and then
you
bring
can
down.
Stop, sir. Okay, that's fine. Okay, you can do the rolling restart at a time. Express upgrade.
Okay.
But okay, you see till now. Okay, now it is installing all the new software. Okay. Now also your cluster is green only. Your services are up and running only. Correct or not?
Correct. Yes.
Okay, so there is no problem till now. Okay, I will tell you what is the place where it will stop the services and start the services.
Okay.
During installation, it will not stop anything, it will not start anything. Okay, so now also my cluster is up and running.
So it is something like how we do the YAM update. Once during YAM
Of
update,
course, yes, sir. End of the day,
will happen, right, sir?
Yeah, backend, okay, the same thing, YAM update only happening.
Correct, sir. So nothing will happen. Only later, once everything is installed, then only we need to restart the server or something.
Yes, sir. Yes, sir. So it installed, okay. Hive installed, Hadoop installed, Snappy installed, okay. Sage installed, Kafka installed, HBase Phoenix installed, okay.
So here we need to, so even in case of Express upgrade, we still need to do an M update on all the individual nodes, right?
No, sir, no. Are we doing, okay, did I do M upgrade? See, the UI is doing now. This process is doing M update and all.
Yeah, but before you have run some update on the cluster.
Those are for, okay, no, those are only for UI and the agents. Okay, that is okay. Manual M update.
And okay, that is a manual. But this is
this Hadoop
this is kind of
stack and all automatic.
Stack and all automatic. Okay. So the agent one, we need to log into each and every individual node and do it, or we can do it from one single node.
One, okay, from class machine, okay, you can do it all at a time.
Okay.
Okay, that's what I did, right? All at a time, okay, I did.
Yeah. Okay.
Sir, in our background, I can see Zookeeper Harshan is a Hesabdam.
It can be, sir. Okay, it can be. They may downgrade or they may upgrade also. It's up to them.
Oh.
If they feel like there is a new version, okay, they felt that okay, there are some bugs in the new Zookeeper 3.1.5. Okay, then they'll give it 3.1.4. Okay.
Yeah.
Only one node is done. Other nodes are still happening. Please bear with me for 10 more minutes, guys.
Sir, can we be able to? This is a request. Can we be able to do one session on, like, you know, if there are any real-time issues on the CDP side, like let's say. We are getting these alerts, right? The clock offset and due to the entity mismatch, and the Hive Metastore, Hive is not able to create a catalog database within the time limit.
Yes,
so like any simple any alerts that you can be able to shed some light on, and what are the actions we need to take?
Okay, we will see, sir. But okay, you note down all the alerts. Okay, so I'll try to. Okay.
Sounds good, sir. I'll come up with some, like, let's say 7 to 8.
Okay. Yeah. Done. Okay. So now, so it is installation is completed now. Okay. So now perform upgrade. See, this is the place it is asking us what upgrade, what type of upgrade you want. You want rolling upgrade or express upgrade? Till now, cluster is not stopped. Okay. So, but okay, if I want to perform express upgrade or rolling upgrade, okay, it is saying there are two required. What are these two? Okay, we'll see. Okay, so the first one is auto start must be disabled. Okay, just you take another version of another this one. Okay, so here, so service auto start. Okay, it is saying that you disable this one. This is what it is telling. Okay, so the second thing is that okay, the following services should have the okay. What are those services? Run again. Okay. So for these services, okay, we need to have Scoop HDFS. So go to click on Scoop, click on Run Service Check. Then HDFS, go to HDFS, Run on Service Check, Run Service Check. Then Page, click on Page, Correct, run service check. Okay. Then Kafka. So click on Kafka, run service check. Click on Zookeeper, run service check. So this is what it is asking. Do these service checks. Okay.
Sir, what does, sir? What service check does, sir? Actually,
it is asking to do a service check, whether it is working or not.
okay. Just to confirm whether
Yes,
everything is
okay.
fine or not. Okay.
Yeah. Now, okay. Just say okay. Okay. Again, okay. You check. It is still saying that one is required. Tej, it is okay. Rerun. Tej is still okay. Now you see. Okay. See, now I can go with rolling update or I can go with the express update. Okay, the checks are passed here. Okay, so we will go with the express update. Click on this one. See, now this is the time, okay, where your service stops, okay, will come into picture. Click on proceed. Okay.
So, sir, in express, everything will be stopped and upgrade will be performed, while as in rolling, one by one it will be.
One by one. That's it. That's it. So in express, okay, if I have 3 zookeepers, so all 3 zookeepers will be restarted at the same time. But in case of rolling, okay, first it will take first zookeeper, then second zookeeper, then third zookeeper. It will go like that. That's the only difference.
So in real time, sir, we do rolling only generally.
I guess, okay, you joined late, sir. Okay. It depends, sir. Depends on the requirement. Okay. So now it started the upgrade part. Actual upgrade part, it started now. Okay. So upgrade is getting initialized. Okay, it will show you one by one. Okay, so now it is stopping. See, now it is stopping everything. See, it is stopping. Okay, Spark services, Hive services. Okay, Yarn services. Okay. See, this is the place it is stopping everything, guys. Got it? It stopped. Okay. So now it is okay. It is saying okay. Please take the backup of all these things. Yes, okay. We have already taken. Proceed. So if you still have any services, okay. So Kafka, Phoenix, HBase, okay, all those things are getting stopped.
Venkat sir?
Yes, sir.
In one of the stack, any service need to be upgraded. Then entire stack need to be updated or only?
Yes, sir. Yes, sir. That's what I told, right? Yes, entire stack. Sir, only suppose like if there is an issue, okay, only with Zookeeper existing version, they'll give you the new patch. Okay, so you will not update. They will not allow you to upgrade the version. Okay, so they'll give the patch. There's any issue, okay, let's say there is a Zookeeper 3.4.5 we are using, there is a bug inside that, they'll give 3.4.5, okay, so new patch. They'll fix same version, they'll fix the issue and give you new RPM. Okay, but they'll not allow you to upgrade. But when it comes to upgrade, you need to upgrade entire stack. Okay. So HDFS, okay, name nodes are started. Okay, then data nodes, restarting all the data nodes. See, all the restarts are happening at the same time parallelly. But in case of rolling upgrade, first it will restart data node 1, then data node 2, then data node 3. Like that it will go. That's the only difference case. Now, okay, if you see this one, okay, so this is almost cluster stopped. Now cluster is stopped. Okay, Zookeeper is started with the latest version. Okay, now it is starting with the HDFS, latest versions. Okay, data nodes are starting. Yes, yes. Yes, Kafka started, HDFS started, Kafka also started. See, Kafka started, it has become green. MapReduce is starting. Okay, so MapReduce is starting. This will become green now. Done. Okay, so yeah, then it is starting the yarn. MapReduce also done. Okay, it is starting yarn now. It is starting with the node managers and resource managers. Now you can see yarn also green. Okay, so it is restarting with all the new versions. Okay, now only left out things are okay, Hive and Spark, only two. I don't think it HBase also. Yes, I don't think it will take too much time.
Sir, what is the difference between update and upgrade?
It is upgrade only, sir, not update. Update means okay, the same version, okay, you are making it update. There is a bug, you are updating it, the bug to the new patch. Okay, there is update.
That means version not changed. Update.
Version is not changing. Yes.
But in upgrade, the version is not changing.
Yes, yes. As everything is started, now it is performing all the service checks. STF system is doing Kafka service check. It is performing Yarn service check. Performing MapReduce to service check.
Sir, after upgrade, any issue in that version, can we roll back the old versions?
Of course, yes, sir. Yes, sir. You always have an option to roll back.
Okay.
Okay. But I will show you that also. Till when we can roll back.
Sir, how do we know the bug in a software? మనం ఎలా తెలుసుకుంటాం సాఫ్ట్వేర్ లో బగ్ ఉందని ఏదైనా ఆప్షన్ ఉందా?
No. If developers are using that software, they are facing some issues. But then we can check whether it is an issue with their code or with the service itself. Got it? So you are using calculator. Okay, you are saying 2 plus 3 equal to 2 plus 3. Okay, you are expecting 5, but it is giving 6. What does it mean? Huh?
Understand, sir.
Sorry for extending today, guys. I cannot stop in between also. That is the problem. We can see service is so much time. Normally it will not take this much time, HBase. There's no error also, it's going on. But normally this will not take this much time. So far 85% is completed, guys. Overall upgrade. So I can ignore and proceed, okay? Because okay, anyway, HBase, okay, anyway, it is green, right? Okay, so you can ignore and proceed. Now it is starting Hive and Spark because 2 more services are yet to start. So it looks like Hive is started, guys. Okay, so now it is starting the Spark, which is the last one, right? Hive is started, the Spark is the last one. Finally, it is doing the service check for Hive. Yes. Okay. Okay, guys. Okay. Your cluster version has been updated. Okay, so guys, okay, so this is very important thing. Okay. Till this place, at any point of time, if you want to downgrade, you can downgrade. Okay. But okay. So there is a step here. Okay. There is something called finalize later and finalize. Okay. So what normally people will do, okay, so they upgrade the cluster and they give it to the developers for a testing purpose. Okay. Okay, so they will say finalize later. Okay, so click on. Okay. So you should not do any of these operations. That's what it is telling. Okay, fine. Okay, finalize later. Okay, so current. Okay, so dismiss. Okay. So now this is the upgrade. Okay. But okay, it is not yet finalized. Now, okay, so this cluster will be given to the users. What they will do, they will start doing some tests. Okay, so they'll run some sample programs and all. Okay, if they feel that if there is any issue, okay, and if there is a requirement to downgrade, okay, they will have an option to downgrade. Okay, resume upgrade, and they can click on. Okay, they can click on. Okay, they can click on for downgrade. Okay, but okay, let's say the clusters, everything is fine now. Now they are okay with this one. Okay, if they click on finalize, once they click on finalize, okay, they cannot roll it back. Understand, guys? Once they click on finalize, they cannot roll it back. Now I'm clicking on finalize. Okay, after this, I cannot roll back. Now this is 100% completed. Yes, this is 100% completed. So now you can see only one version. This is the latest version. And okay, if you see the old versions and all, okay, so upgrade history. Okay, you can see upgrade. Okay, so this is the from this version to this version. It is completed on today. Today it is start time is 9 to and end time is 9:21. It took around 18 minutes. That's what it is saying. So this will show you the restart time only, guys. Okay, so 21 minutes it has taken to restart. It means these 21 minutes only, or this 18 minutes only, you'll have the downtime. Okay, remaining time, your cluster will be up and running. Okay, so now the cluster is everything is upgraded, and now it is running with the new version. Okay, so guys, that's all I have. I guess we extended a lot today. Okay, so we'll stop it here and we'll continue tomorrow. Thank you, guys. Thank you.
Hello.